Hi everyone, my name is Silla, and for our hydroponic class, me and my partner Jessie worked on growing lettuces and pak choi in our hydroponic system while testing how different pH levels affect plant growth. We used a method called NFT, or nutrient film technique. NFT is a popular hydroponic system where a thin film of nutrient-rich water continuously flows through tubes feeding the plant's root. It is efficient because the plant gets constant access to water, nutrient, and oxygen without being submerged. The water then drains back into a reservoir, gets recycled, and then pumped through the system again. For our crops, we chose a summer-adapted variety of lettuce, which belongs to the Acer family, and pak choi, a type of Chinese cabbage from the brassica family. And even though these crops are both leafy greens and thrives in similar temperature and pH ranges, they absorb nutrients in slightly different ways. So our main goal was to study how different pH levels of 5.0, 6.5, and 8.0 affect plant growth and quality. And we also measured other things beside the pH in EC, which was the canopy area. We measured it from north to south, east to west, and we measured the height to see how wide and full the plants grew. We also measured the fresh biomass, which is the weight of the plant right after harvest, the dry biomass, the weight after we dried all of the water out, the anthocyanin content, which relates to the leaf color and stress responses, and the chlorophyll content, which indicates how healthy and green the plants are. So now to our system setup. Our NFT system had 20 tubes draining into 11 buckets. Only the middle 18 tubes were used for the experiments. The tube at both of the ends were excluded, so they were not used. Each tube had 12 planting holes, meaning we could fit up to 240 plants across the whole system. And each bucket had its own pump to keep the water moving, so in total there were 11 pumps running at once. For fertilizer, we used Jack's Professional LX 15515 water soluble fertilizer, and we adjusted the mix so that the water had 125 parts per million of nitrogen, which is a key nutrient for the leafy greens. And to help us mix fertilizer and water automatically, we use a Dysotron injector with a 1:100 ratio. In our first iteration, we filled each bucket with 56 liters of fertilizer water, and in the second iteration, we increased it slightly to 62 liters to better support plant growth. And managing pH was one of the biggest parts of our experiments, because plants prefer different pH level depending on their type, and even with the slight shift in pH can change how well they absorb nutrients. So we use pH up and pH down solution to adjust the pH level of our fertilizer water. And we also used the grow line pH and EC monitor to measure the pH and EC, and we made sure to calibrate it carefully before each time we use it. And one mistake we made was not adding a pH buffer when we started, and because the pH buffer helps prevent the big swing in pH between weekly adjustments. And so after seeing unstable pH after the first week, we corrected it by adding a buffer solution at 0.225 milliliters per liter of water. In the first week, the pH across most buckets was far off from our target of 5, 6.5, and 8. We had to spend time adjusting each one using pH up or pH down. By the second week, we noticed a drastic drop in pH and realized we had forgotten the buffer solution. After adding the buffer, the pH level started to become more stable. So by week 3, the pH values were more consistent and closer to our target range. However, by week 4, when it was time to harvest and take final measurement, the pH was not close to the ideal range we want at all. The bucket for pH 8 was lower than what we expected, and the bucket targeting pH 5 and 6.5 was slightly higher than what we wanted it to be. In iteration 2, we made a few key changes. First, we adjusted the pH a week before planting, which gives the water time to stabilize. Second, we added the buffer immediately to prevent early pH fluctuation. And third, we only planted lettuces because we forgot to start the seed for the pak choi. In week 1, the pH was close to what we wanted, so we didn't have to adjust it very much using the pH up and pH down. In week 2 and 3, the pH stayed very stable, and by week 4, there were only slight variation from our ideal pH level. So what I took from this is that planting only one crops helped to stabilize the nutrient absorption rate and the pH. So in our previous experiment, we grew lettuces and pak choi together, and so that can cause the different nutrient demands between the two crops, cause my pH level to fluctuate more. So even though lettuce and the pak choi thrive in similar environments, their nutrient uptake can still be different. So planting one type of leafy greens is more helpful in the second round of our experiment.
Alongside EC and pH data, we also measured the average biomass. Here in iteration 1 for lettuce, we see that the highest fresh biomass was in the pH of 6.5, with pH 5 and 8 having lower but similar biomass yields. Overall, the root biomass data was harder to properly collect since the roots were easily ripped and tangled when we were trying to pull them out of the NFT tubes, so the data for the roots is somewhat weaker compared to the shoot data. And then in iteration 1, we also measured pak choi. The pak choi showed mostly the same trend of pH 6.5 having the largest biomass yields, although pH 8 was very similar in yield to pH 6.5. And then here in iteration 2, we only measured the lettuce since we forgot to seed the pak choi. This data trend was interesting because at this point our pH adjustments were much more honed in. Again, we find that pH 6.5 yielded the highest biomass. We also find pH 8 was slightly lower, and then pH 5 was much lower compared to the pH of 6.5. In iteration 2, we implemented some new techniques that helped us in our experiment. The biggest help was the sampling map and the sampling tags. The sampling map acted as a guide to tell us which plants to sample. Essentially, we blocked off the perimeter plants and the middle 6 plants of each tube. This gave us the outer plants, which we could more easily reach over to measure with rulers. We also used ChatGPT to randomly select which 3 plants would be sampled from each tube. The sampling tags were upgraded as well. Previously, in iteration 1, we had the sample tags on top of the tubes, which worked fine for the pak choi, but were easily covered by the lettuce plants. So in iteration 2, we put the sample tags on the side of the tube. With the ease of measuring, our activities became increasingly easier to do. Similarly, we got better at scheduling our activities. We mainly measured the sample plants on Monday, then on Wednesday we refilled the buckets, recorded the before pH and EC, then we adjusted pH, and then we recorded the after pH and EC. If we were to do this experiment again, I would add an extra day to adjust pH and refill the buckets so that the pH is much more stable. I would also use pH up and down solutions that didn't include plant macronutrients like potassium or phosphorus. I would have preferred the pH adjustments to stay in the fertilizer water instead of also being uptaken by the plants, leading to pH changes. I would have also preferred more calcium in the fertilizers since we did experience some tip burning on the lettuce and pak choi. Alongside our data, we also assessed the general quality of the lettuce. We found that overall pH 6.5 had the nicest lettuce. It was not too green, not too compact, and not too chlorotic. However, with pH 5, we found that the lettuce was very dark green and very compact. And then on pH 8, we found the exact opposite. pH 8 had much larger leaves that were highly chlorotic and yellow. The overall growth of the plants was very good. The first 3 weeks usually had at least a doubling in size, with the 4th week usually tapering off in growth, but still significantly grew from the previous week. And then here we show the rock wool we used to grow the transplant. And then in this slide, for refilling the buckets, we had to turn the solenoid valve and then turn off the vine crops drip system. And then we turned on the 125 ppm nitrogen fertilizer in the dosatron, which was set at an injector ratio of 1 to 100.